Good evening, or good morning, or good afternoon. Who knows what time it is for you? What time is it right now.com? No, I'm kidding. That's a small joke if you watch the show BoJack Horseman. Welcome to another Twitch stream. I'm very excited about today's stream. I hope you are too. As I hinted at last time, we are going to be looking at data from Netflix. And this isn't just any data. This is my, or I should say our, personal data of our usage of Netflix, meaning me and my partner. And so first of all, maybe first things first. Welcome to the stream. If you're here for the first time, amazing. If you're back, if you're watching for the second or who knows how many time, then welcome back and thank you for joining again. I am Maddie, or Matthew, or Maddie Two Shoes, and I like everything that has to do with data. And so I stream about it. And today in particular, we are going to be looking at importing and working with a data set, because on previous streams, it was actually already done for you. I loaded in and that was it. You could just watch me analyze data or work with data. And that's a little bit too easy. I mean, for streams, that's great. But in reality, it's a little bit different than that. I mean, those of us who work in the business know that we spend a lot of time modeling and trying to figure out what data is what and if it's in the right format, etc. But yeah, we are going to be looking at that today. And so also an important point, I have explicit consent from my partner to also show, or how should I say? Sorry about this. 1 second. I was just a little bit distracted here trying to bring up something. So I have explicit consent from my partner to show and work with the data that we have today. And yeah, that's basically it. So I think we will do the logical thing and we will switch over to the thing that we want to do, which is work with data. So I will switch over. Oh, that wasn't very nice. Let's do the right way. There we go. So that's the fancy way of switching over. And this looks fairly empty because we haven't done anything yet. So in case someone will ask, we are using DataGrip, or I'm using DataGrip, and you're watching me use DataGrip, product from JetBrains. It's a very, very nice IDE, so user interface for working with databases and data in general, and doing SQL and things like that. And so yeah, why is this empty? And do let me know if chat is, if music is too loud or too quiet. It's always a bit hard to gauge on my end. So we are going to do something about this empty setup. So first of all, I will create a new schema here because we're going to need one. I'm going to call it Netflix usage. And I'll get into a little bit about what kind of data we're looking at in a second. But it is important to talk about how I obtained this data. So this is not data from Netflix itself about their business. I have to make that very clear because the title of the stream may be somewhat misleading. This is data that Netflix has collected with our consent, that being said, and stored about us, so about me and my partner. And it is about our, let's say, preferences or behavior in using their product. And I have made a GDPR request. So if you're not familiar with that, it's a regulation concerning data privacy and storage of information that can be linked to an individual. So this isn't about, it's not about storage of data in general. It's just a regulation concerning storage of data that is very personal in nature. And yeah, I made a GDPR request, a data request to Netflix for a copy of all of our data. And they kindly provided that. And I will say they provided that very extensively and very quickly. So there was a nice little process, a tool that you could use to make a request. And yeah, you could just basically get a download of your data. And so that is what I will show. Yeah, what I will show today. One very important note, sometimes I may need to blur the screen before showing you something because I haven't fully explored the data set yet. I have looked at it a lot, but I haven't fully explored everything that we're getting, and that's kind of the point of this stream. But at the same time, I need to retain some of my privacy, even though you know who I am. There may be some personal data in there that I don't want to be shown. And like I said, I have consent from my partner and also obviously my own consent here to show our usage habits. And we have a few questions about what our Netflix usage is like. But we will probably only get to that in another stream, to be very clear. Like today is really about importing this data and working with it. If we're faster than I think we're going to be, then we can already start doing some analysis work. But today is really about getting it right. So yeah, so I'm just going to do a little switcheroo here. So sometimes I will blur the screen. It will look like this to you, where everything's a little bit pixelated. And that is because I'm just looking at something that I need to see and you don't need to see. But then I will always toggle it back so that you can see what I'm doing. And the first thing we need to do is actually look at the data that we got. So I'll just have to open that up here. Give me 1 second. And if you're joining, write in chat and say that you're here and let me know where you're joining from. Curious to know where everyone is tuning in from today. So, where is this data folder? Here we go. So, I think I can show this. All right, so this is the data extract that I got from Netflix. And let me just take you through a little bit what we got here. So there's different levels of information. There's profiles, social media stuff, surveys, payment and billing, messages, IP addresses, devices, customer service, content interaction, clickstream, and account. There's also this document with additional information telling you how they comply with data protection, which is super, super cool and really detailed, but probably boring for most people. So the first thing, account details, I believe, I'm just gonna pixel, I believe this is like, yeah, so this is my personal information about my account and also some subscription history information. That's gonna be, we're obviously not gonna deal with that. So what I'm gonna do is actually I'm gonna create a little folder here called I'm just gonna call it consent given. And so what I'm gonna do is just rename this to have it on top. So I'm gonna have this consent given folder, and I'm gonna put the stuff that we have kind of the okay for on the stream, and the other things I'm just gonna call it private. So the account information, I'm gonna move that into the private. So then we have this clickstream data. This clickstream data file, if we just preview that, sorry for the white blindingness. There's a profile name, there's a TV source, navigation level, and then there's some refer information, web page information, and some timestamp here. And in some cases, don't know where that was the case. Let me just look if there's one here. Oh yeah, in some cases, there's like some additional information here. Not always. I'm not really sure. Like there's some search history in here and stuff like that. But this is, yeah, clickstream data. I assume the clickstream is from the actual Netflix website product. But I could be wrong. This is something we're gonna have to figure out. I don't know if it actually says in here. If it describes the file. I don't think that it does. I was looking through it, but I didn't see. No, I didn't see that. So the additional information, whatever, that's fine for the stream. We can put that in here. So the clickstream data, we can also put that in here. Content interaction. So this is pretty big. I'll come back to that in a second. Let's see if we can go through some of the other stuff first. There's also this cover sheet. I'm not sure what's on there. Give me 1 second. So this is about the information request. There's a description of the data. Look at this. So they tell you everything's in UTC. Notations such as -1 or null indicate no or deleted information, blah, blah, blah. So there's an account. They tell you everything that's in every single file. This is actually really awesome. Okay, so we need this for figuring out what everything is afterwards. That's very important. All right, so we have customer service. Customer service, I believe, is just chat and stuff like that, which I will just put into private. Devices concerns the devices that we use. And those probably shouldn't have shown that on stream, but we're gonna just put that into private as well. IP addresses I already know I'm gonna put in private. Messages, I'm actually not sure. I think these are messages. Oh, right, these are the push notifications and things like that, which is also very interesting. And I would like to look into that. Maybe there's also some kind of pattern we could see. Payment and billing is not interesting. Then we have our profiles. So this is just for, I guess, for you as a stream to know. We have basically the right to have 4 profiles. And we have 3 of them. Or rather, yeah, we have basically 4 of them actually used. We have 1 profile for like it's set as a kids channel, and that's because we had Netflix set up in our in the room that we have 2 bunny rabbits in, and sometimes we would leave Netflix running there, and we didn't want those recommendations to be played into our other profiles. Then we have a profile for each of us and a profile for us together when we watch together. And the reason for doing it that way was because the recommendation engine is very strong in recommending content that you've already watched. It has a lot of what's the right word? Tendency, or it has a strong preference to recommend content based on what you've watched, not only what you click through and stuff. Which makes total sense, right? I mean, that's a logical thing. But we didn't want my partner's habit to also influence the recommendation engine when I'm watching something on my own, vice versa. So we made those 3 separate profiles. Anywho, social media connections is private and survey data is also private. In case there were some responses in there, I don't think I actually participated in any surveys though. So, now what, you're asking? I mean, no one said that, but you may be asking, okay, now what? What are we doing now? What we are going to do now is look at the last one, content interaction. So, content interaction, that was here. Indicated preferences. Upon first use of a profile users are invited to select TV shows and movies they watched before they subscribed to Netflix. Interesting. Then there's the interactive titles. So if you're watching an interactive title where you're able to make choices, it actually shows you what choices you made, saves them. My list is your list functionality, playback related events. This is the one that's going to be really interesting. This table provides details of actions taken during a viewing session of an episode of a TV show or movie. Profile name, playback start, country. Then there's play traces that took place during the playback. Then there's all the ratings, our search history, which maybe we should be a little bit more careful about, and viewing activity. So the name of the profile in which viewing occurred, length of the viewing session, and these are attributes about whether it was auto-played, whether it was marked hide. Yeah, really like a lot of detail. Sorry, I didn't mean to close that. Where were we? Yeah. So like all the titles and bookmarks from where you are in the actual movie. Like this is how they know where you left off and things like that. So it's actually super cool. And country. This is very interesting. Yeah, so this is going to be, obviously the content interaction is going to be very important for us to look at. I am going to actually take the search history out because I think that's something that should stay private to us. I do have my partner's consent for that as well, but I do not consent to actually showing our search history. I'm fine with showing the other things, but yeah, for that I think I will draw the line. And this is something, consent is a general topic in data collection, but I'm not going to go into that today. I actually did a previous stream where we talked a little bit about that. So yeah. If you have questions at any point, just put them in chat. I'm curious to hear what you want to ask about, because this is a little bit of a different stream. We have not really covered data import and figuring out how to actually get the data in there in the first place. And I think it's an extremely important topic, because you will spend a lot of time modulating or transforming or changing how data was given to you in the first place. It's really not that simple as just downloading a file, putting it in a database. It's really not that straightforward. Sometimes it is that easy if you're just looking at one thing from the internet where someone's giving you some really clean data, like if you download it from Kaggle or whatever. But in a real business context, you will not have that kind of clean data. And actually, I just have to turn off Time Machine, sorry, because it's actually backing up at the moment. I didn't want it to do that, because it's going to cause more load on my laptop. So yeah, now what do we do? So the first thing that I would start to figure out is what kind of structure am I going to put in this Netflix schema here. So the structure I'm going to go for is going to emulate what Netflix has given us, because I don't think that it makes sense to try and derive a different structure for data that they're giving us. That being said, we can obviously go deeper if we feel like we need to go deeper. So for example, there's like clickstream data, and in the clickstream data, there may be like some nested stuff. We may choose to, I don't know if there's, I don't know, up here, if there's like some nested data or something, then we might, I don't know, we might, I don't know, we might like put it in some other format. But in this case, I think the clickstream table, that's pretty easy. So what are we gonna do? We'll just do import data from file. Now I have to go, where was that? Here we go. So we have this consent given, and then we have content interaction, clickstream, right? So clickstream.csv. So now this is the import window for DataGrid. My Postgres database is up and running, and I can import my data directly to it, and it stays there. And when I don't need it anymore, I can shut it down again because it's running in this Docker container. That being said, if you want to do this in some other database, there's nothing wrong with that. Like, you can do this in any database architecture. I'm just showing it with Postgres because I think Postgres is a really nice solution, and personally I prefer it. But it works with any structured database type. So we have all these fields: profile name, source, navigation, refer URL, webpage URL, and click UTC TS. I'm purposely not going to modify these columns because, I want to retain the original naming that Netflix had. Normally I would like lowercase them and put underscores in between the spaces and stuff, but it's going to take too much time. So we have, the table is called clickstream, then there's each profile in there. There's 472 rows. No, there must be more than that. And we will select import, and if there are any errors, they will come up here, but it looks like that worked just fine. So now we have all the clickstream data in here. How many rows do we have? 3,000 rows. That's pretty cool. And these are all the timestamps. I actually don't know how long we've been on Netflix for. I think 2 years, maybe 3. I'm not 100% certain about it. In any case, yeah, so that's the first one imported. That was easy, right? Super easy. So let's do the next. We have to, where was that here? So we have to now do the content interaction. We could do the messages one just to have that done. Maybe that's also easier because then we can spend a bit more time on the content one. So messages from Netflix. So we know that these aren't our messages, right? So we have profile name, sent, message name, channel, country, locales, email locales, all kinds of stuff. Email domain for whatever reason. Might have to truncate that. Although doesn't seem like an issue. That's fine. So now we have our second table. Easy peasy. Messages from Netflix. With a lot of messages, 900. Wow. That's really a lot. It's really a lot. Very interesting. All right, so that is that. Now we have the final ones. So we have to figure out what, what are we gonna do now with this last folder? I had a bit of brain fart moment, sorry. So what are we doing with this last folder? We have like these preferences that were indicated when I joined Netflix. Ah, here we go, 9th of December, 2018. There we go. So yeah, just over 2 years. All right, that's pretty good. These are things that apparently I gave them, but actually we can't really infer anything from this. I mean, it's super basic. There's not even any flags here for these shows. I think there was just shows I was interested in or something. So there should have been an is interested flag here, but that's obviously not the case. Yeah, I mean, no biggie. So we'll just leave that. Interactive titles. This is the choices we made in the show. So this is very interesting. To be honest, without knowing what choices were available, it's not so useful. I mean, it's interesting to look at, but yeah, it's not really possible to kind of infer anything from it. I mean, there's like this one default line, but other than that, oh, I don't want this. Didn't mean to double click that. Yeah, there's this one default line, but other than that, there's really nothing to be said here. There's our lists, which, well, I mean, yeah, I mean, this is just what's on our list. I don't think it's that relevant, other than when the stuff was added. I think it could be interesting to use the title as part of the usage. So there's in the playback events, there is the title. Oh, this is a bigger table. So there's the title description, but I don't know if it's the same title as here, because this is title name. I don't know if, oh yeah, so ratings are, for example, in the titles, but well, I think my list is probably not that useful. It's not even that big anyway, so so there's that. So basically, indicated preferences is a no. So I'm just going to make an X next to the ones that we're not doing. We're also not going to do the interactive titles, and we won't do my list. All right. Ratings we should do. That makes sense. Not a lot of ratings though, actually, which seems really odd, because I really would have thought that we've rated way, way, way more shows than this. That's interesting. Because that's such a small amount, I think that's not something I would include, purely because of the size of the data. So then there's these two about viewing activity. This is very relevant. And then there's the playback related events. These are the ones, that's the gold mine, right? These are the ones that are really interesting. Ah, you see? So here we have like some nested data in here. This is what I was talking about, is that not everything will always be so clean, right? You can see here that there's different event types and stuff. So we're gonna have a lot of fun trying to process that. All right, so viewing activity. Let's try that one first. That's the easier one. Viewing activity. So we're going to call this activity viewing. All right, we'll just name it as they did. Why not? I'm renaming the tables because the file names have camel case and I don't like that. Yeah. Like, as always, if you have questions or you want to know anything or you just want to say hi, just write in chat. There hasn't been anyone writing till now, but that's no problem. I'm doing this primarily for me, and if people also want to watch, that's fantastic. Viewing activity. So what do we have in here? We have the profile name, we have the start duration of the viewing activity itself. That's very interesting. There's also the attributes in here. We'll probably have to split those out or something. Supplemental video type. We'll have to look up what some of this stuff means. PS4, like device type. We primarily watch on PS4, by the way. We're not going to have to do any analytics for me to tell you that we primarily watch on PS4. Okay, this seems all right. So importing all the clickstream data. The advantage of having everything locally, by the way, is speed. I mean, this is absolutely lightning. Okay, it's 3,000 rows, not that much, but this is really cool. So that's the clickstream. Oh, sorry, that was the wrong one. 4,000 rows. It's interesting how the viewing activity is actually really short. It's very interesting. So I can't remember when I did the export. I believe it was... Where was it? Why is there no... Ah, here we go. I think it was the 1st of February or something like that. So it only goes until the end of January. Because that's what they captured. So, yeah. So that's that. Now we do the other one. Playback related events. So if we just go to import this, I'll show you what happens, right? This is where we might have to think about having a different structure. If we just select this, so it's going to expect a CSV, so comma separated values. And you see these play traces here. It's just text. It's a massive text block. Now, I don't think that's the right way to do it, because we can actually specify that this is an arrayed, and by putting these two square brackets, and I don't know if that's going to work in the preview, or and we should definitely try it because it will make working with the data easier. That being said, nested stuff, I think this is JSON. It looks like JSON with keys. We'll figure that out in a second. First, we're going to try and import this now. I'm just going to import it with the standard naming. I'm not going to change it for now. All right, so how big is this thing? It's still importing. This one's obviously a little bit bigger. So you can see here it's processing at the moment. I guess it's taking a little bit longer, also because the nested information. Because normally for 10,000 rows, it would not take this long. Ah, so there was an error. It wrote it to a text file. Yeah, so malformed array literal. That's not good. Yep, so that didn't work. There's also some like all my other ones from all the times that I've tried importing stuff and it didn't work. So that's nice. So that didn't work, that's fine. We will drop the table and start again. And this is like a trial and error process for me because I don't work that often with JSON formatted data in a database context. So it says we should put this in text. So I'm inclined to just leave it as text for the moment. Should also be a lot faster to import. Oh yeah, look at that. 5 seconds. how many rows? 10,000. So we're gonna just rename this playback related events. We can just call it playback events. Doesn't need to be so long. Refactor. There we go. So we can split off the information in this table using some SQL. Should we have done it during import? Nah. This is like the kind of thing where if you are running a professional data pipeline and professional database and not doing this in your free time with like, you know, not in a business context, I don't think it's a big deal to just work with this in database versus doing it beforehand, like with cleanly and everything. But in a business context, I definitely would look at splitting this out beforehand and maybe doing other tables and stuff like that. But we can work with this already, and then we can figure out what to do with it after. If we want to put it into some separate tables and join them up with like an event key, we could definitely do that. One thing I want to do is auto numerate, so we have an ID for each of these rows, but I'll come to that in a moment, because there is a function for that in Postgres. We even did it as part of yeah, it's row number, that's right. We even did it as part of data camp a few weeks back, the row number function. So just if I do, like, I could have done this, to be clear, I could have done this during import, right? So if I import data from file and I do this again, so we're going to call it playback events new. I'll change this afterwards. We can do this by inserting a column where it's auto incrementing. We can call this ID. And we can call playback, let's call it playback ID. Playback event ID is even better. And there's this little option here with not null auto incrementing unique primary key. And these basically append all those conditions to the creation of the table. And then what happens is you get to, when it creates the table, it will automatically apply these conditions. So maybe not primary key, although for this table it is the primary key. So let's do that. And when I import this now, in this new table, you see there's this event ID here. This is just the row, like the way that it imported it. So if I order by this one, it might not be the right order in terms of timestamps, because sometimes it's out of order for whatever reason. It's just the way that it serializes when it imports. But yeah, this is like one way of doing it. The other way of doing it is basically when it's already there, if you just do, so I have to make this bigger. Let me know if the font size is too small for you on stream. I can go bigger, but it's a little bit inhibitive for me to write, but yeah. So if I do select from Netflix usage playback events, and I do this row number here, why didn't it capitalize that? So if I do this row number and call it, I don't know, playback event ID, then I have the same thing, but it's ordered as the table was imported. So I could order it in the way that I want and say, okay, each event is given an ID and the earliest events get the first ID. So for example, this one is earlier than that one. So if I do order by playback start UTC descending. This is like the most recent one. Oh, I need to put the order by in here too, don't I? I believe so. Order by playback descending. So this one will get the first row ID, the row number. And then I could export this and re-import it with that, which is a bit silly, right? I mean, I prefer maybe the auto numerical way, let's be honest, because it's much nicer to have this ID in here and it's already in there on import. And this is something that if you design a real database architecture with nice schemas and everything, you're going to want to have these keys so that you can join things together. Definitely. Anyway, so I prefer this, but because the event ID itself is not important, this is going to get dropped because we don't need it. If we want to make rows, we can do like that, but I really don't think it'll be needed. So let's make this also more legible. We have like titles and stuff. Now the question is, of course, what do we do with this? So we have all the data in here, just to be clear. So we have everything that we want to work with, but not in the format that we want. So what we really need to do is figure out how to split this stuff. And for that, we need to take one of them and look at what it's actually composed of. And we should probably take a short one because it's just hard to work with a longer one. The first thing we're gonna do, Netflix usage, playback events, we can just do length of play traces. And we can actually just do a little thing here with figuring out what kind of lengths we're dealing with, like how long are these different things. Oops, let's do a little order by in here. All right, so these are short. This is empty. So there's a couple of them where it's empty. 993. There's quite a lot of occurrences. Oh, sorry, this is the length. There's 993 occurrences of 261 length. So let's look at some short ones here. 61. So what we'll do is we'll just include the play traces here, like this. Take out the count. This is PL length. We can use this as in our where condition again. And again, if anyone has questions here, feel free to ask at any time. Really, this is about also collaborating on this kind of stuff. If you want to know something specific, or you just want to say hi, that's also fine. And if you're watching, how are you? Let me know how you are. Where are you watching from? Where length is less than 62. And then we get just the ones that are, oh, we don't want the short ones. So between 50 and 62. All right. Oh, these are the 61s, even better. What about longer ones? There we go. Interesting. Go a little bit longer. Okay, so these are just some information about those. So this is like an easy way of sort of exploring what kind of data is being sent. This is what I wanted to see. So I wanted to understand the structure, and this is it an object with JSON in it? Because the syntax, so we'll copy one of them out so we have it. the syntax is square bracket, comma, another curly, square bracket close. And each one within, oh yeah, it does look like JSON, doesn't it? This could definitely be JSON. Which is cool, but not sure how we're going to split this out. Basically, what we want to figure out is the easiest way to generate for each of these rows. So we have like an ID, if you would imagine each row having an ID. And each row then has additional properties with it. So the event type, session offset, media offset, there could be other ones too. And the reason that it's stored here in one line, in one text thing, actually I want to change the station 1 second here. Let's go to this one. Oh, there's nothing in there. Interesting. Oh wow, really? Okay, wait a second. No music in here. There we go. A little bit quiet, maybe. Oh, that might be too loud, actually. Someone let me know if it's too noisy. Oh yeah, that's probably going to be too noisy, isn't it? It's always hard when you change stations to get the right volume level, but I think we'll leave it like this. So anyway, the reason that it's all in one row is so that they can store each event on one line. So you have an easy count of all the events in that table. You could just do select count star, right? And you have like an event count from this table if you don't have the where condition. Just like this. So you have 10,794 events, right? Playback related event. But of course, if you want to know more, about what these events were, then you'd have to kind of drill out these fields. So maybe, well, let's just start playing around. We should append a row number. Row number. Oh, I really don't like that it's not uppercasing it. I'll have to check in my settings later. Over order by. What are we gonna take? Playback start. Ascending. Playback event ID. Just so we have something. So 2018, 2019, this looks correct. Wonderful. So, before we get into any analysis work, right, this is just about parsing the data and figuring out if it works. So we'll take a row number and we will take a playback start UTC. So playback start UTC. I'll just reformat it a little bit. What else do we need in here? Oh, of course, we need the play traces. So this is take me apart, please. This is what we want to split. There's a few different functions we can use to split data in Postgres. Let's see what Google tells us. So what do we have here? Postgres JSON. So the field is not JSON, but this is definitely JSON in an array. Luckily, it's not nested, because that's nice. We might encounter some nested stuff, but I hope not. Ah, look at that. There's some native operators we can use. So let me just make this smaller here, so we can actually see this at the same time. So we've got this operator, which returns the JSON object field, and this one which does the object field by text. Very nice. So this is the key and this is the value. Very cool. Okay, but we'll have to convert something to JSON first. So split array into JSON. Oh yeah. Efficiently. Ah, doesn't this look like what we have? It does. Yeah. Cumbersome. Okay, but I want to extract. String aggregation. Okay. With item. How did we do this? Oh, interesting. JSON each sub items. Wow, okay, this is very, very... Ah, JSON B. Okay, let's cast this. See what it looks like. Oh, that looks a lot nicer, doesn't it? Let's check this out. Postgres JSON B. How to work with this. Alright, so JSON B. One of efficiency. JSON B is stored on decomposed binary format, makes it slower, but faster to process, blah, blah, blah. Okay, we don't really care, but essentially, if something is a JSON, here's a nice little article. Oh, hi Lily, sorry I missed your message. I'm fine, thank you. I hope you're well. What is your objective? My objective right now is to split the information that I have here in these play traces, so in these basically playback events, into separate columns and values. So basically columns for the keys, so event type, and rows for those values. And then we could start with the analysis work, potentially. Yeah, potentially. So we have JSON B. Have you worked with JSON data in SQL before? For me, it's a relatively new thing, so this looks fairly cool. Let's see how we can do this. So this is like JSON data. Just making a little common table expression. So yeah, when I was looking at it, I saw that it had this JSON structure, so I just cast it here. But in theory, I definitely could have imported it directly as JSON instead of text. But you know, that's something you find out later. And for context, maybe if you're only joining the stream a bit later, this is actually an export of all of our usage data from Netflix for me and my partner. So, and I have her consent, in case you were going to ask, to analyze this on stream to see if there's some interesting watching habits, or also some interesting habits about when Netflix wants to send us messages. But in order to get to that point, we have to process this data a bit first. So yeah, this was just a test with the shorter ones. I'm sure there's ones that are a lot more complex. What I want to do is figure out if we can do the syntax here. So select, we should probably rename this, play traces JSON. So play traces JSON, single object, event type as play trace. Let's do event type. Oh, that doesn't work. Oh, because we already had an alias here. Oops. My bad. That's what happens when the font's too big. Get this out of the way. So play trace is JSON. Oh wow, okay. So that didn't work. Good to know. Maybe needs to be in double quotes? No, that doesn't look right. Ah, I see. Hold on a second. We don't actually have... Question is this actually JSON? Because we have the array on each side. Oh, we could just left trim to find out if that's the case. Let's remember how the left trim function works. I think it's this, and then 1, and then JSONB. Text integer does not exist. Why does that not work? Oh, I could use both actually. Remove spaces. Oh, but that's only... Remove array brackets. Why? I don't understand. Why is it like remove arrays? Oh wow, okay. It actually takes out the array. Square brackets. Regex replace? Oh, B-trim! Yeah! Nice. That's really cool. Get rid of those. Thank you so much for reminding me about B-trim. Invalid input syntax for type JSON. Ah, so it wants that. Definitely wants that. Yeah. I'm thinking there's got to be a regex to extract everything after quote and before quote for the JSON dictionary keys. Yeah. But I mean, this seems to be with the, oh, where was it? Oh, there's also a nice medium post here. Let's see this. If you want to query a simple field. So it's like a hat. It's like a hat. I mean, if I can just iterate over it, I could probably write some function to do it, but I think let's just try it out for now. So this doesn't get... We write with double hats. No. Doesn't seem right yet. The operator gets a JSON object field as text. Select metadata from users. Postgres 9.5 plus. Yeah, we have like a super... It is very cool about the JSONB functionalities. Like, if I can get it to work, then I'm just concerned that this isn't... Oh, maybe it's not working because it's JSONB. No. But it's interesting how it changes. So there's no spaces here, and if I put it in JSONB format, it actually inserts spaces in between. It's very interesting. So I'm gonna leave as JSON for now. Let's do JSON query instead. PopSQL, I like their site. Params, blah blah name. Oh, give me the first index of a JSON array. Maybe it's an index problem. JSON query in array. So let's see. There is a JSON function. So there's this JSON data play traces JSON. Oh, this doesn't actually do anything? JSON data. Aha, right, that's my alias. Great one. Do you even know SQL, bro? No, that's... okay, so JSON array elements text from JSON value. Okay, play traces JSON. Event type. Matches the given name and argument types. No. From JSON element index integer. Let's try with the... Oh, here we go. This is the first element of the array. So basically, if you would take this in JavaScript, so 0 is this one here. Yeah, this, oh, okay. This makes total sense to me now. So this is 1 and this is 0. Okay, so what we would do is we could actually somehow iterate to get each element, and this would be JSON array 0. Can we do this in one go? Because it would be very convenient if we could do this in one go. From play traces, cast to JSON. Looks like it could work. JSON array 0. Wow. This is very cool. Okay, so let me just explain what I did in case you didn't quite follow, because I also need to review this. So basically what we have in this row, in one cell, or in one column, in one value, we have a nested, so everything chunked together. We have a nested array of JSONs. And so each of those JSONs within the array is a array element. An array element. I just heard myself say ray element and it sounded like sort of laser beam stuff. So I just wanted to be clear that it's an array element. Need to have good enunciation. So what we can do is maybe figure out if we can Postgres JSON iterate over element JSON element index. Because what I would want to do, someone has asked this. If I want to know, if I don't know how many elements there are in the array, I mean, of course we can count it, but I want to not have to write 200 of these. Yeah, with a for in loop, which I've never done before. We could try this. For each. What? For each element in JSON array 0. Oh, sorry, wait. If I don't take it, oh, we'd have to get each element out separately. Let's see if we can do this without doing it here first, because I think probably shouldn't do it if we don't need to. So we want to do play traces JSON and call this play traces JSON. All right. For each element in play traces JSON, select do we even need? I need to copy this out. Can't follow it. So how does a for each work in SQL? This is not something I've never done before. Sorry, I just had to sneeze. There is a loop statement. Oh. Okay. So it's loop. So we have a loop, and then we have statements. Typically use an if statement inside the loop to terminate it based on a condition. Wow, okay. This got complicated quickly with exit conditions. Okay, it's like JavaScript, basically. Let's do... let's look at a nice loop example. See, I don't like their examples because they're very abstract. Oh, here's nice. What is looping? Oh, here we go. For blah blah blah. Oh, so you could do a function. Reverse order looping. Wow, this is really hardcore. Let's try with the medium post. Create a function? Wow, I've really never done this before. This is really advanced. Wonder if we actually need to go this far. No. Maybe not. We look at Stack Overflow and we don't know. ELGP. Set-based solution. Pure SQL equivalent. Oh, with cross-join. Lateral? What is that? I've never seen that before. Well, that's generate series, which I don't really want to do. I suppose. That's a bit annoying. Interesting. Insert into. I just don't know how many arrays we will expect. Maybe we can count it and then we can figure it out. This is beyond my understanding right now. So we have play traces JSON. Can I do array count? Array. Count number of array items. What is the right way to do this? Oh, okay. Wow. Unnest. Sum the array length function result. Really? Any array, play traces JSON. Array length JSON does not exist. Because it's not an array anymore. Right, if I do cast as JSON? No. Ah, here we go. JSON array length. Okay. So now we're getting somewhere. From JSON, we're gonna use play traces JSON. All right, so JSON array 0. We would have to iterate this normally, but I'm just gonna 1 and 2. Just call this 1 and 2. Very cool. All right, let's put this away for the moment. I need more space here. All right, so we've definitely gotten farther now. Now we have to figure out what is the length of these each ones, right? Because I'm actually curious to know what is the max. Because this will dictate, oh god, we'd have to iterate this 320 times. Ooh. Yeah, that's not gonna work. So we would have to do this 320 times, which is obviously out of the question. So what we can do is we can just start with 1 and see how it works, and then if we can get it automated, then we can figure out how to iterate afterwards. Sound like a plan? And this is what I meant about today not getting into analysis work, just for FYI. So JSON array length is the length. We could order by sending. So these are the really long ones. Oh wow, there's some that are, oh right, there's some that are 0. Where we can just say here for a length greater than 2. Voila. And yeah, so 1 array length, fine, it's perfect. Where array length equals 1. So how do we split this now? I think there is an unnest function. So if we unnest this, what happens? Oh. No, that doesn't work. So unnest JSON. All right, it would be called flatten. I think there's a way to do it. JSON call. I tried using unnest, but it doesn't accept JSON-B. Use JSON array elements. JSON. Okay. What? Yeah, here. You want to do some table, blah, blah, blah. JSON B to record set. With a lateral join. Oh, that's interesting. Okay, so JSON B to record set. We could try this. JSON B to record set. JSON to record. Oh, we would have to do this afterwards. Right. So let's try JSON parsing as. Put another one in there. Start from JSON parsing. This is what we have, and now we do JSON record. JSON to record set. JSON array 0. Could not determine row type. Provide a non-null record argument or call the function. Hold on a second. I see. He's done a cross join. Okay, we should limit this to 1. Just to have one record. Select. Oh, what would this be? Event type dot name. Column definition list is required. Oh, I missed something here. Hold on. JSON array 0. I'm gonna call this as specs name JSON required Boolean. I don't know what that's doing actually, but I don't know what specs dot event type. No, it's gonna be specs dot name. Must appear in the group by. I see. Group by 1. Specs.name. Could not identify an equality operator. Oh wow, that's fascinating. JSON to record set. Okay, I have mine. Okay, let's look up this function a bit more. Because I think this is the way to do it. Ah, but now that it's JSON, couldn't we just use the operators? Get JSON object field. Wait a second. Maybe we're going about this all wrong. So that's one possibility. I don't think we need this anymore. Did you leave me, chat? Did everyone abandon me with this complex exercise? I think that we can do select JSON array 0. Oh. What was this? I think it was event type. Oh, I don't want this stuff anymore. Yeah, okay. So this works. This most certainly works. If we select each key, unnest JSON Postgres. This is it's very interesting working with this data. JSON array elements from JSON value from JSON array 0, I want event type, for example. Okay, that doesn't work. Integer doesn't exist. How do you turn JSON array into Postgres array? Ooh. JSON array elements text, JSON array elements text. Yeah. Event type. Aggregate unnested elements per row in a lateral or correlated subquery, then original order is preserved and we don't need order by, group by, or even a unique key. Oh, I see. So select something from that, cross join lateral, from string aggregation. Wow. This is array constructor. Very interesting. (9.3) or older? No. Use the function JSON array elements, but we get double quoted strings. No, that's not our problem. So we could do like this with the cross join lateral. I think that is the way to do it. So we have our JSON array. You know what? Maybe there's a little fiddle here that he linked. Yep. Let's check this out. Table ID, blah, blah, blah. So he's got an ID. And then he's got... Okay, that's fine. So let's take the array length as our little key here. And then we have the values. That's the function. I don't want the function. So array length from JSON parsing. This is going to be A. Okay. Then we've got cross join lateral, which I've never done before, but this is the first time for everything. And then we're going to do select string aggregation. And this is D. So D dot lm text. How does it reference itself? That's what's really fascinating for me. Ah, I see. Lm text as list from. Okay, we already have a JSON array element text, right? Wait a second. So this is his data set, and we have, hold on, let's just do a little check here. So this is what we have, that's what he has, which is definitely the same. So we have the right data. So we'll do from JSON array elements text from a dot JSON array 0, and it's not called tags, it's called event type as DLM. Cannot call JSON array elements text on a scalar. Oh, hold on a second. We also need d.list. Okay, it's still having issues with this. So maybe it just needs this. Oh wait, it's doing it twice. Would it be hold on a second. JSON array element text. Cannot call JSON array elements text on a scalar. What's the issue? Filter out null JSON values. There's no JSON operator, so cast to text and compare. I want to see if this function is doing the right thing. From JSON parsing. Yeah, so this is already the problem here. I wonder what the issue is here. Data is JSON. I was able to get this select to work. Okay, let's check out the fiddle. Oh, is it that simple? Oh, I don't want, but I want to build it out. That's the thing. This is beyond complicated. Get JSON objects. Maybe we've been doing this all wrong. JSON array 0. At specified path to JSON returns the row as a JSON object. Ah, hold on. Oh, come on. There must be just JSON to row. Postgres. No. JSON to record and JSON to record set. Okay, let's try this again. Willing to give this one more go. So we have an array length and then we have something. Let's call this calls, because he also calls it calls. From JSON parsing. JSON to record set. Well, let's do like he did, okay? So this would be it. Your JSON value is JSON array 0 as rows, JSON to record column, blah, blah, blah. Where is this coming from? Let's check it. Sorry, I just got pinged. Don't really understand your JSONB value. JSON each. JSON array elements. We have that. JSON to record set. PostgreSQL. Easy, no? Yeah, okay. This should be simple. Create table, insert into... Oh yeah, so we have an ID and then our entire array. Oh, that's nice. Okay, so select... We didn't even need to do this step. We could already have play traces JSON. We could already have that like this. Let's try like that. So play traces JSON. This looks promising, to say the least. Select array length. That's a terrible name, I realize now. Let's just call it array ID for sake of argument. Sum A, sum B from JSON parsing, which is cross join lateral JSON to record set J dot play traces JSON as X group by array ID. Oh. Interesting. Why does this not work? Because it sums. If we do min and max, no? Column definition list is required as A varchar E varchar. Is this what it is, that we just have to define what these are. Oh. We're getting closer, my friends. So it doesn't know how to do this, maybe because it's the whole thing and not just a JSON. Let's try with JSON array 0 instead. Cannot call JSON to record set on an object. So that doesn't work. Play traces JSON. Why are these null? It's definitely doing something. So that's that. Record set. Expands the outermost array of objects. Populate record set. Outermost array of objects to a set of rows whose columns match the record type defined by base. Oh. Why are we not using populate? Does it have to be JSON B? No, JSON populate record set. Base any element. Yeah, and then from JSON, use JSON as text. It's odd, very odd. JSON2 record set builds an arbitrary set of records from a JSON array of objects. See note below. Reference a table in the from clause. Not helpful. Next. Text. Shouldn't make a difference because varchar is varchar. Gotta close out some of this other stuff. JSON each. Oh. I found out how to break up the key value tuples in this tutorial. JSON each. Ah. Okay. JSON each. JSON each. JSON each Postgres. Oh wait, there was a post here. Oh, that was that. Ha! Very high ranked. JSON each. Oh, good lord. JSON each. So we can use JSON each to translate the JSON into this results set format. So out key text, out value, play traces, JSON from JSON parsing. Cannot deconstruct an array as an object. Ah, see. So we do need our little friend here. JSON array 0. Ah. Okay. Nice. Okay, so this is looking good. Alright, so we have playback event ID, which we should include in here. Len. All right. How do we get rid of these? How do I get rid of these? These. I do event type. No, that doesn't work. JSON each text. Select ID key value from users, JSON each preferences. So JSON each JSON array. What's the original data set? You have a users table with a preferences column. Yeah. Oh. Wow. Holy crap. I think we just did it. I want playback event ID. I want the array length. And I want as I'm just going to name it that because this was very, wow, this was really tedious, but we figured it out, which I'm really happy about. Really, really happy about. So I was a little bit quiet there, but I was just really trying to sink myself into this. And basically, I now understand how this works. What I'll need to figure out is how to handle each of these arrays. Because I don't want to do a JSON each for all of these. It's kind of nuts. Would be pretty crazy. Yeah, not something I really want to do. Okay, so we don't need this for the moment. Yeah, I think JSON each, I mean, basically, there's the ones with 290, so we'll have to figure out how to do that because I don't know how to do that right now. JSON array 1. Oh, wow. That's awesome. Yeah, so we have playback event ID 4, which has two JSON arrays, and this is the value of both of those arrays. Wow, that's nuts. Truly nuts. Never worked with this kind of data before. And seeing that we have to do this 390 times is not the most efficient way. So I will have a think about this for next time, because I think we'll have to do this method of cross-joining. But I need to spend more time investigating this. So I'm hoping that for the next stream on Saturday, hopefully, that I'll be able to actually show how I did it in the end, and ideally also start some of the analysis work. And basically, so JSON parsing, let's call this A or JP. So if we have JP dot playback event ID, and then we'll have 0 dot star j1 dot star. Hopefully we'll have this kind of table that basically each playback event will have a... Oh. Doesn't like the distinct in there. It will have for each playback event the start and stopped. I can see it repeating here, so we'll definitely have to figure out how to do this. Maybe we only need to do it once. Hold on a second. I think I just saw something. So if we do 2, and we only do this once, wait a second, is this right? No, that can't be. That can't be. Unless the values are the same. So this is what we have. We have a playback event. Oh, we should do JSON parsing. Aha, yeah, JSON array 1 has different stuff. Stop, 2378 and 0. Yeah, so that's not... Yeah, stop, 2378 and 0. And then there's... It's just repeating itself because the way that the key and values are aligned. So it's not perfect, but we're getting there. We are definitely getting there. But I'm going to call it quits for today. It's been a long day at work, and also, yeah, a good brain exercise, brain stretch for the evening. Can you actually feed multiple data in here? Ah, I see. I just want to check one thing. So JSON each, multiple JSON. JSON each text function returns the set of rows with key and value column names by default. However, I want JSON each text to return custom column names. Interesting. Oh wow, there's even a Tableau post about this. Join your data with a list of numbers, identify the number of JSONs, and split as required. You really need someone to help you with the solution, and you need to provide some sample data. Oh yeah, so we could generate a series and then loop through. That's probably what we're going to end up doing in the end, is looping through with the generate series function. So we do like with JSON data, JSON parsing, and then here generate series. Select generate series, and then just do our generate series function here. I'll just comment this out for the moment. But yeah, that's I think what we're gonna have to do in the end, because generate values for 0 to, I don't know, 500 for possible number of objects in array. For now, we've only been taking the ones with 2, but we know that this one goes up to like 390. To do here, select star from JSON data. Let's leave this intact for the moment. Do it down here. Just in between here. Select star from JSON data. Yeah, so these ones are really long. They're just like extending past my screen here, right? So we will definitely have to have a solution for those. Yeah. I hope you enjoyed the stream. Those who were watching, was a little bit quieter today, and that's totally fine. I'm going to call it a night here. I think it's a good place to end. I will have to look into this a bit more off stream, but how to get this looking nice and cozy so that we can actually analyze it. Of course, it's like deduplicating here, because I actually have one playback event that has 2 different events within it, so that's why it's like deduplicating these values here. And that's maybe not the best way to approach this, right? Maybe there's a better way to approach this problem. So I need to spend a bit more time thinking about that. Sleep on it, drink, eat on it, all those things. So I thank you for taking part in today's stream. I hope it was still interesting or exciting to watch, even though maybe I wasn't explaining as much as normal. But yeah, I think it's a good result. I really learned a lot about JSON and parsing JSON. So if you did as well, then objective reached. And I hope to see you in the next stream, probably on Friday or Saturday. Again, in the evening, CET, around that 8 or 9 p.m. mark. Usually at 9 p.m. For now, as it's more convenient. But let me know, maybe you want to have it a little bit earlier or a time that's more convenient to you. Let me know. You can put it in the suggestion box on my profile, or you can write me a message, as you wish. So have a good evening or morning or afternoon, wherever you may be. Stay safe and see you again soon.